Hello, everybody. So we're going to get into, well, we've heard about a lot about digital transformation, this convergence of OT, IT, or just, how those things blend. And a lot of people think, well, why haven't they already blended? Why are we having to do this paradigm shift thing? And so that's what we're going to talk about today. We're going to dig into that, figure out why there's such a discrepancy and how we go from point A to point B to get a converged architecture on both sides. So we'll be talking about both sides individually, and then we'll talk about convergence, and then we'll layer on the IoT stuff. So we'll first talk about the IT modality. Really, we want to get in the headspace of the IT person or the IT departments and figure out how they make decisions, why they make decisions, and how that relates then in contrast to OT. So here's how IT kind of thinks, right? First of all, IT people play in the data center. Right? They're not out in a refinery. They're not in a utility site. They're not on a barge. They're not, doing anything outside, really. They're typically in a data center or in an office controlling infrastructure that lives in a data center. And their function is to support the business processes, right? Email and help desk and things of that nature. They're typically business-facing apps. And they all have purposes. They all need to be up, but they're very different than what you find in the OT side of the business. When you talk networking, it's usually Ethernet. It's usually TCP/IP. It's usually switched and routed. It's usually Cisco or Aruba or something like that. And that's all fine and good. That helps to make the world go round. That gets your email from point to point all over the globe. But then when you kind of boil it down, right, the target of their work is systems and software, right? A server or a virtual machine or a container or network equipment potentially. And the software that runs on top of that makes the business go. Over on the right side is a picture of the OSI model, Open Systems Interconnection. And it basically outlines how data gets from node to node, from computer to computer, across a physical wire or physical sets of wires, and then how it's interpreted up the stack to the point where you see Google in your web browser. Okay, and that's kind of how IT thinks. They think very statically in this kind of mode. From both a development perspective as well as IT infrastructure management perspective. Okay. So when we look at the mindset of IT, right, failure happens. They expect failure to happen. They don't expect to put up an email system and have it never go down. And the result of email going down, yeah, some people don't get their mail for a little bit. But it's typically not the end of the world. You might miss a deadline, might have something that gets somewhere a little bit late, but by and large, at least 80% of the time, nothing really crazy happens as a result of an email server. Now, if you've been in the IT space for any amount of time or dealt with infrastructure in IT space, it's all about the nines. Right? It's all about, hey, does this storage platform have 4.9 or 5.9 availability? Does this other architecture, does this server with this particular software have the ability to be up reliably? And IT wants to get everything up as close to 100% of the time as possible, but at the end of it, it ends up coming down to management decisions. Is there budget for it? Is there a priority on this particular project? What's the impact of failure? If something goes down, is the sky going to fall? All those things go into determining how much reliability IT can put into a system. And even if you get components that are 99% reliable, you still have their interconnects or things that are above and beyond the platform you bought that has those nines credentials. And so at the end of it, when you talk a multi-tier system, right, where you have app servers and database servers and clients and maybe some web services out in the middle, all those interconnects as a whole do not have 100% or even 99% reliability. They try, but it's typically it falls short. Another aspect of it is IT people think, oh, in 3 to 5 years, this equipment's going to be obsolete. I'll get new equipment, right? And we'll go to the next level. And that's they kind of expect it. They don't think in terms of decades or multiple decades, right? And IT has just grown so fast, right? The evolution of things has just gone really fast. Everybody's clamoring to keep up, much less stay on top of things, on top of the things they've already deployed. They want to go to the next thing and the next thing and the next thing. So that's kind of the mindset of IT, and that's how IT works. Now we'll talk about the OT side. So the playground for OT is industrial operations, right? It's those plants, those refineries, those utility facilities, things like that. There are many people that are out in the physical environment, out in the weather, working on something physical, replacing pipes or repairing electrical lines, right? Something like that. And their focus is physical processes, right? There's in oil and gas, there's a process that takes the raw materials in, runs through the process, and the resulting chemical comes out, right? That process is what they're focused on. Their job is to connect initially, right? To build these environments up so they can do said process, to monitor them, to see how they're doing, and then to manage and control and secure and do all those things to make sure that it runs reliably. The network, though, has evolved much slower than the IT side of things, right? Let's see. I think this will work. So the bottom 3 layers are now kind of starting to blend into the OT side of things. When you look at the equipment and software platforms that are coming from the ABBs and the Rockwells and the Siemens and those types of companies, they have now all pretty much adopted some sort of Ethernet with some sort of IP above it in order to communicate across those different devices into the control center. So they are adopting the technologies that we evolved in IT and now putting them into the OT context, which is great. But when you look at anything that's existing or has been existing for a number of years, you're not going to find Ethernet typically, right? You're going to find Profibus and Modbus and OPC UA and other things like that might run over serial lines, right? It's not going to be what we know from the IT side in the existing architecture. As we move forward, we are seeing a good merging of IT networking capabilities into the OT side of the business. And then as you look at the top part of this graphic, the blue graphic, these 3 lower layers, the network, data link, and physical, all kind of marry up into this OT related graphic. Remember, the OSI model is more IT related. Those relate into this bottom aspect, and then you work your way up into production and inventory and business, IoT business stuff and things like that. So that's how that kind of plays. Now, when we look at the OT mindset, their mindset is failure canning, right? When failure happens, money is lost. When a chemical plant stops producing because a pump fails, they are losing money for every second that that pump is out of operation. Okay, they put in equipment expecting that it's going to be there for potentially decades, right? They spend more money on robust hardware to make sure, or to do whatever they can to make sure that it will be a viable solution indefinitely going forward. Okay, and they kind of focus on these deterministic, reliable protocols instead of doing the technologies that we've used in IT, where we have the concept of being able to resend packages that don't make it, but these guys don't want to not have a packet that doesn't make it. They want to have packets that make it every single time. That's what they're going. Special purpose stuff, right? It's not generic stuff that you customize to suit. It's very specific purpose, very purpose built, and does its job. We already talked about that. Slow evolution. We mentioned that. IT has been fast. OT is very slow, and it's because of the put it in, let it run for decades type of process, the cadence that they've been accustomed to. So what's missing in OT is a lot of the things that we are now doing more in the IT side of the business with analytics and things of that nature, or in the case of like a connected worker play, where you want to have your workers out in the plant be able to communicate or get help or enter your desire of choice here while they're out there, and not have to go back in, talk to somebody, come back out and do what they were told to do. They want to be connected, and a lot of this is enabled by network connecting those types of environments, right? But really, what they're focused on is those industrial transformation leaders, right? That's what this graphic on the bottom is. Those people who are looking at how to blend these environments. They are looking to increase revenue, reduce COGS, increase operating margin. And as a result of blending these two, they are able to increase those or get better results from those capabilities. And that's what we're really trying to work, right? We want to make people safe. We want to make things efficient. All that kind of rolls in and gets better when you blend OT and IT together. So now we'll talk about how they converge and what people are doing today. So the first, or the way we traditionally done it, is we've had the two systems completely isolated, right? IT does their own thing, OT does their own thing, because the minds just don't meld, right? They don't trust each other. They don't have the same methodologies and approaches. And so they don't benefit from each other as a result. So we need something different. Now, the first toe in the water is really about taking OT information, the data, right? The information from all the hardware, all the sensors, everything, bring some of that specific data over into the IT space, where they can do some analytics jobs or do some correlations, do something to try to optimize and better utilize the equipment that is in that plant, right? That's what they're trying to do. As you do that, trust begins to grow, right? They start understanding, because they're now talking. They start understanding how each side thinks, what makes them tick, why they'll get better results if they start working together, things like that. Now, when you go to the next stage, you start to blend, right? So there's now bidirectional communication between the two sides. So you might have automated data push from the OT side, analytics happen, automatic data push back from the IT side. Now that doesn't mean that the IT data that's pushed in is actually controlling that OT, the OT hardware, right? It's not necessarily making decisions to turn something on or off, or increase throughput or decrease throughput based on that information. But it can be staged. It can be put in a place where the people that are making those decisions to do the controls can look at that and then act accordingly. But it could also be that it's the beginning of automation, where they do the analysis comes back, and something is automatically changed on the OT side. Once that trust is strong enough, once they understand how things are playing together. But you still got to kind of think about it from the perspective of IT people and IT systems may fail. So if they don't trust that that system is going to be up and operational when they need to do this analysis, then they can't really trust it to give that advice back, at which point they can't trust it to make operational changes. So it's not quite there, but this is a better scenario. This is got that whole leg in the water. So now what we really want to get to is something more like this, where we have a convergence of the two. Now, at this point, they trust each other, or at least the people that are working in this project trust each other. What I kind of look at this as is the concept that we run things like high performance computing environments in, where there is an air gap between the normal IT systems or the desktops and things like that, and this high performance computing system. Or another analogy is black programs, top secret programs at our defense contractors, right? They have to air gap things. They have to make things separate because of the security, criticality, whatever. There's many reasons to do it. But in this case, you don't necessarily have to say all of IT trust all of OT. You have to pick those very good people from both sides who get it and bring them together onto the same team where they have the same goals and they're needing to do things together. And with that, then you can get the best out. Then you can say, I want this OT data to feed into this analytics, and I want the output of that analytics to come back and make changes to the actual operating environment. And that's when things will change. It's not going to be for everybody in IT to go do this stuff. It's going to be for select people to participate in this kind of thing and put those OT and IT systems together on the same network with a common goal. And that's how we'll get there. Now, when we talk about IoT and IIoT, there's not really a difference. I mean, IIoT is all about industrial things, right? It's a subset of IoT. IoT is huge, but IoT typically talks over TCP/IP. Your internet connected refrigerator, or your Alexa, or any of those newfangled things that are coming out, they're all talking on IP, TCP/IP. When you look at IIoT devices, they may or may not, or they may gateway between a profit bus or mod bus to TCP/IP. So there's elements in there that are different. The IoT things many times, not always, but many times, have very specific functionalities that you don't get out of the general purpose IoT stuff. And gatewaying is a way to get them to talk on the Ethernet or Wi-Fi or whatever. So here's just some examples of what you'll find. General sensors, temperature sensors, you can get those for Raspberry Pis, and you can do interesting things with them. But you're typically not going to find that same kind of caliber stuff out in the IIoT space, where they're looking for determining whether or not a pump is going to fail before it fails, right? predictive analytics and things of that nature. Then you got some of the players down here that that they care about. Now, I mentioned that you may need to go through a gateway in order to bring that data from the OT side into IT type technology. We use PTC's Kepware and Kep server for that. That's one of the platforms that does very well at bridging that gap to say, I have 50 different sensors that talk 30 different protocols. How do I make them, how do I get the data into something that's common that I can then do good analysis on? So Kepware is the middle. And then many times as an IoT platform, we'll use PTC ThingWorks, right? We can bring it in, we can create dashboards and mashups and all kinds of interesting things that that both show us data and then allow us to analyze it and change the operational control. Now, the way we typically go about starting one of these processes is we prefer to do what we call a quick start. We get everybody who's got skin in the game into a room, and we go through an exercise to make sure that everybody is on the same page. And 95% of the time, they are not on the same page walking in that room. And it's very eye-opening and very interesting to find the results of doing this experience where we can actually get people to then follow that one path down that gets us to point B, right? And that's how we start is with a quick start. And that's all I've got. Oh, are there questions?